So how do machine learning models learn and make predictions? Machine learning operates in two key phases: training, where the model learns from data, and inference, where it applies what it has learned to make predictions. Let's start with training. So model training in machine learning involves feeding a model a data set and adjusting its parameters to minimize the difference between its predictions and the actual outcomes. Several key aspects define this process, including the learning mode, so it can be supervised or unsupervised, the training set, algorithms, model parameter optimization, iterative processes, and continual learning. So in case of iterative processes, the model is trained on a dataset until it achieves satisfactory performance, often involving training multiple models and comparing their performance on the held out validation set. So we'll talk about validation later. But the idea is that it's an iterative process and you may end up training multiple models. Now, continual learning allows the model to continue training on new data, also known as stateful training, fine-tuning, or incremental learning. We'll talk about fine-tuning later when we discuss LLMs. Now coming to inference. After a machine learning model undergoes training, it goes to inference stage. In the inference stage, the model generates predictions based on new unseen data by applying the patterns it has learned. This process involves prediction generation and can occur through online or batch prediction using an inference pipeline. Prediction generation uses learned patterns to generate predictions on new inputs. Now, inference can be performed online or in batches. Online prediction involves generating and serving predictions to users in real time or near real time, often requiring a streaming pipeline to extract features from incoming data. On the other hand, batch prediction generates predictions for a batch of inputs, typically in an offline setting. Now, one important topic here is transfer learning. Transfer learning is a machine learning technique where a model trained on one task is adapted to a different but related task. So instead of training a model from scratch, transfer learning leverages pre-trained models to improve efficiency and performance, especially when level data is limited or expensive. So the key approaches in transfer learning are feature extraction and fine-tuning. So feature extraction is about using pre-trained model layers to extract useful features from new data, whereas fine-tuning is about adjusting a pre-trained model by training some or all layers on the new dataset. Now, some examples of transfer learning can be, say, using a model trained on ImageNet to classify medical images. So ImageNet is a popular dataset for vision-related machine learning problems. Now, another example can be adapting BERT or GPT for domain-specific text classification, or applying a speech recognition model pre-trained on general audio to transcribe dialects. Transfer learning significantly reduces training time and enhances model accuracy with fewer data points.